this is problem number 32. Sometimes you've got no choice other than to do the calculus, and fortunately for us, the calculus here is pretty straightforward. So we've got losses due to fire are being modeled with this function right here on 0 to 20, and we're asked to find the probability that the losses exceed 16 given that they exceed 8. So I'm going to do a little bit of a visualization before we do any of the calculus. It's just to sort of refresh what's actually going on here. This line right here is something like this. We'd start up here at 0.1, we'd come all the way out to 20, and down here at 0. And what we're saying here is that knowing for sure that we are already past 8, how likely is it that we are going to be past 16? So given that we are in this region here, how likely is it that we're in this region here? So it's still just conditional probability. We've just got some integration to do in order to get our answer. So let's wipe that away. And I like to simplify first as much as possible. So distribute through 0.1 minus 0.005 x dx, and we're evaluating from 0 to 20, but because we have these conditions of 8 and 16, I'm going to go from x to 20, create a little bit more of a generic formula. And so from here we roll the integral up and get 0.1 x minus 0.005 x squared over 2, and we're going to evaluate from x to 20. So maybe to be super clear, let's not use an x, let's use an n. So we know we're thinking about an integer here. And then we can simplify a little bit here, go full decimal. 0.005 divided by 2 is going to be 0.0025. So I'll make that change and then evaluate the integral. Plug in the 20, 0.1 times 20 is going to give us 2, minus 0.0025 times 20 squared is going to give us 1, minus, and then we'll do the substitution with the n. So 0.1n minus 0.0025 n squared. And that looks like natural log, which isn't so good. But this is an n, and this is a 1. There we go. So simplify and distribute. We get 1 minus 0.1 times n plus 0.0025 n squared. And then that's it. That's a generic integral. It's going to give us the area underneath the curve. And we've just got to convert this into a statement that we can use. So the condition is that x is greater than 8. So that becomes our denominator. So we plug in 8 here. And if you do 1 minus 0.1 times 8, so plugging in 8 for n, plus 0.0025 times 8 squared, you get 0.36. So I'm going to simplify it out here instead of writing out every little bit. That should be something that very easily goes into the calculator. The numerator is going to be the same, but we're going to use 16. 1 minus 0.1 times 16 plus 0.0025 times 16 squared is going to be 0.04, which reduces to 0.1 repeating, or 1/9. So correct answer here is B. Pretty straightforward problem. Just got to do the calculus, and then remember that this is conditional probability. So this statement here tells us how we limit the sample space to where x is greater than 8, and then this statement here tells us the thing that we're looking for given the condition.